Hello everyone and welcome to lesson 3-8 on page 239, divide decimals by decimals. Okay, so let's start with a simple problem here. 36 divided by 9. These are both whole numbers, so I want you to see a pattern that we're going to explore in a minute. 36 divided by 9 is 4. Okay, I want you to pay attention on how the decimal will move places and how it will change the answer, okay? Remember the vocabulary we've learned. This is the dividend, the divisor, and the quotient. So as you can see, we have 36 now divided by decimal 9. The decimal place has moved once to the left. So what happens here is that we have to, now the decimal here moves once to the right, and it becomes, we essentially add a 0. Another way to look at it is the divisor is in the 10th place, and our quotient is in the tens place. Our divisor is in the 100th place, and our quotient is in the hundredths place. Our divisor is in the thousandths, and our quotient is in the thousand. And here, 10,000ths place, and we will have if we keep the pattern going, we will have our quotient in the 10,000th place. So how can we describe this pattern? Well, as we make the observation, we notice the first thing is that the dividends are all the same. They do not change. So go ahead and write that down. The dividends are the same. And as we were saying, each time the decimal point moves of the divisor moves one time to the left, as we did here, like this, one time and then again another and then again another. Each time the decimal point of the divisor moves one place to the left, and the decimal point of the quotient moves one place to the right, as we were seeing here. Okay, it kept moving to the right, making the number larger. Go ahead and copy that down, please. This is part of your key answer. Pause the video so you can copy it down, because I will move ahead. Okay, now let's look at how a different pattern here with the dividend being changed. When the decimal of the dividend moves to the left, what happens? Well, when a dividend moves to the left, the quotient also moves to the left. Do you see that? So when the dividend, the number that's being divided, moves to the left, so will the quotient. And the divisor stays the same. Okay, the decimal point of the dividend and the quotient move one place to the left each time. The divisors are the same, as you can see. Copy that down, please. Pause the video first. Okay, now let's look at the third one. You see that here it moves once to the left and also here once to the left. And what happens to the quotient? Okay, the quotient remains the same, right? Here moves twice to the left, and this one twice to the left, 3 times to the left, 3 times to the left, and you can notice that the quotient does not change. So let's write this down. The decimal point of the dividend and the divisor, so both of them, move one place to the left each time. The quotients are the same. Please pause. Now we're ready to try an example. Let's try here example 2 on page 240. And first, before we do this, 2.64 divided by 0.6, let's estimate. And we always round before we round our divisor and dividend before we can get our quotient. So if we were to round this to the nearest whole number, we'd have 3, right? 3 would be our number there, and this one is closer to 1. So 3 divided by 1 is 3. So our answer should be in the ones place, and it should be something around 3. Okay, let's see. What do we do here? Remember, the rule is that we have to move this decimal. Now, I don't know if you remember this from class, but we have to, in order to divide decimals by decimal, we have to move this decimal over 1 until this number becomes whole. This time it would only be 1. If it were 2 decimal places, we'd have to move it twice. But right now we only have to move it once. So when we move it once on this side to here, we must do the same thing to our dividend. Okay? So whatever you do to one side, you must do to the other, just like fractions. So now that we've made this a whole number, okay, this one became 26.4, and the next thing that you do is just place the decimal right at the top, and now you're ready to work. You're ready to just check to see how many 6's are in 2. You have none, but you don't have to write the 0 down. And then how many 6's are in 26, and you know it's 4, so your first number here would be 4. But the way the textbook explains it is that we have to multiply this number by 10 multiply it by 10 in order to make it a whole number. Okay, see? That's the only way we can get the decimal to move to the right, by multiplying it by 10. Okay, to get it to move one place to the right. And then multiply the dividend by the same power of 10. Okay, the dividend, this dividend that we have here, the 2.64. Okay, we're going to multiply it by 10. And as we do that, you notice here that they did it, right? We have to place our decimal right where it goes. Let's place it right above, right there, right where it's supposed to go. And we know that 6 into 26 is 4, gives us 24, so we're going to subtract that. We get 2, we bring down the 4, and 6 into 24 again is 4. Then we subtract the 24, and we get 0. And there you go. Please copy this down. Okay, now we're ready for the 3 examples where we can try it ourselves on page 240. Let's try A, B, and C. First, let's set it up. Okay, let's set it up. Let's set up the dividend divided by the divisor for all 3. Okay, make sure that you have this written down as well so that we can start working. So if you need to pause the video, go ahead and pause the video. Now, always remember these two flip around. I noticed that some of you were making this mistake where you were dividing 1.7 divided by 54.4. No, it's the other way around. Remember, this one goes under the little, I guess you can say, the little terrace or the little roof. It goes under it, and this is the number that we're trying to see how many of these are in this number. Okay, since we're ready to work now, let's move this decimal over 1 so that we can make decimal 1.7 a whole number. And if whatever we do to this side, don't forget that we must do to the other side. So then we move it over here, and since it's there, now we can put it right where it goes. So now in reality, we're seeing how many 17s are in 544, right? Because these decimals are gone. So how many 17s are in 5? None. How many 17s are in 54? There's 3. 3 will give me 51. I subtract, I get the 3, and I bring down my 4. And now 17 into 34 is 2, right? 34, done. So my answer is 32 for the first one, equals 32, just like that. Okay, next one. Okay, notice how the decimals move 2 places. Okay, on this side, they move 2 places to the right, and so we have to do the same thing to this side, 2 places to the right, and we put the decimal right on the top. Now, from this point on, I'm just going to turn the audio off, and you can see how the answer will build. Please pause the video. Try it on your own if you haven't already. Try it on your own and then check your answer. So as you can see, our answer is 23.4. 23.4. Okay, not the neatest writing, but you get the point. Okay, let's try C. Go ahead, pause the video, try C on your own. Remember to move the decimal places enough times over until you get the whole number. That was 3 times, so we must do the same thing here. 1, 2, and 3. And there's our 3 times. Okay, I hope you paused the video and tried it on your own. Now, let's see. 7 into 6, we have 0, right? There's none. And then 7 into 63, that's 9. 7 times 9 equals 63. Subtract. So our answer is 0. Our answer up here is 0.9. And there you have it. If you take a quick look at example 3 and example 4, they're just showing you exactly what we just did. If you move it over once, you must move it over once on the other side. If you move it twice, you must move it twice on this side. And let's continue practicing. Again, as I mentioned, please write down the process, how you will divide it. Remember that this number is being divided by this number, so this number is under the little roof. And same for the other 2. So it should look something like this. Okay, and now let's go ahead and move all the decimal over as many times as we need to make them a whole number. So here we have 1, 2, 3. There we go. So I moved it 3 times, so I must do the same here. 1, 2, I add a 0, and 3, another 0. Okay, so it becomes 5,600, or 5,600. Over here we already have a whole number. 200 is a whole number, so we don't have to do anything to this number. And then over here we have a whole number, so we don't do anything, and we don't do anything here either. So we're ready to work. We have 14 into 56. If you multiply 14 times 4, you will get 56. Okay? And when you subtract, you have 0. But wait a minute, the decimal is all the way over here. So what becomes of these two numbers? They also become zeros. Because really what you're saying now is that 14 times 400 is 5,600. And that makes sense. If these zeros weren't here, these zeros wouldn't be there. Okay? Then it would just be 14 times 4 is 56. But it's 5,600, so this number automatically becomes 400. Okay, 200 times 6, none. And don't forget, we must start by putting our decimal up, so we have 0 there. And then 262, none. And then 200 into 624, we have 3, which gives me 600. Subtract, I have 24, right? I bring down a 0. It gives me 2, so now I have 2. It gives me 200. Oh, I'm sorry, 1. I did that wrong. 1. 200 times 1 is 200. And now I have 40. Bring down another 0. Now I have 400, so now it's 2. I was jumping ahead a little bit there. Okay, there we go. So 0.0321. Now please copy these down up here. Okay, copy these down right in that section. I don't have a lot of space and it's hard to do it with this pen. Okay, 25 into 4. We'll put our decimal up first. We have none there. We have none there. When I make put a 0 here, okay, 25 to 40, I have 1, right? So I write 25, 15, bring down a 0. I have 150. 25 times 6, there we go, it's 150. Subtract, and I have 0. So it's 0.16. For example 6, we have a question comparing two different numbers. So for example, how many times as many internet users are there in Japan than in Spain? Round to the nearest 10. So we want to know how many more times there are in Japan than in Spain. In order to figure that out, we have to find out how many in the population of Spain are there in Japan, right? So we have to divide the number of Japan by the number in Spain. When we look here, we have internet users in 2008 in the millions. Japan has 127.4 million internet users, and Spain has 40.4 million users. So we're trying to see how many more times Japan has than Spain. In order for us to figure that out, we have to see how many of these numbers are in here. So just to find out how many more times. And that's what we're doing. We're taking 127.4 million divided by 40.4 million. Okay, and then we just follow the rules. Move the decimal over once here, you have to move it over once here. This is the numbers you have. You divide normally as we've done. And now Japan has 3.15 more times internet users than Spain. So you could say Japan has 3 times more the amount of people online than Spain does. Okay, here we have our guided practice as we normally do. Please leave this for class. This will be a nice warm-up that we can do together to remind you of what we will be doing that day. And here's your independent practice. You are ready to try this. Now that you've seen me work on examples 1 to 5, right? These are all from examples 1 to 5, all of them. Go ahead and try them. You can do them. If you have any questions, go back in the video and look at how we did 1 to 5. But quite simple. Remember that this one is under the little house, under the little roof, and we're finding out how many of these are in here. And we move this decimal over 1, so we must move it here over once. Okay, don't forget that. Then you have the word problems. You can always look back at example 6. Remember that usually we're trying to find out how many there is of one number in another number, or how many times bigger is one number than another number. So you can try these two, and we'll check them in class. Okay, see you then, boys and girls.